Let's zoom out and look at the big picture of 3D printing. No matter what type of 3D printing you're doing, whether it's FDM, SLA, SLS, or even metal 3D printing, the overall process follows the same broad steps. Understanding the 6-step journey will help you stay oriented throughout the course. And more importantly, it'll help you troubleshoot, improve, and iterate effectively when you're printing on your own. Let's walk through this generalized 3D printing workflow step by step. Step 1 is design, creating or sourcing a 3D model. And this is where it all begins, with the digital model. You can create your own 3D designs using softwares like Tinkercad, which is great for beginners, or Fusion 360, which is more advanced and engineering friendly, or Blender, which is great for organic shapes or art. Or you could just download pre-made models from online repositories like Thingiverse, Printables, or Cults 3D. Just make sure that the model is printable. Whether you're designing from scratch or remixing something existing, this is where your idea takes shape. Step 2 is data preparation, exporting a clean 3D file. Once your design is ready, it needs to be exported into a format that your slicer can understand, usually an STL or a 3MF file. But before you slice, it's important to also make sure that your model is watertight, meaning that it's a closed manifold 3D shape with no holes or errors. Tools like Mesh Mixer, Netfab, or even built-in repair functions in Fusion 360 or your slicer can help you fix these issues. Think of this step like checking your ingredients before you bake a cake. If you put in garbage ingredients, you're going to get garbage out. Step 3 is slicing, preparing the file for your 3D printer. Slicing is the process of converting a 3D model into instructions your 3D printer can follow, layer by layer. Different 3D printers have different slicers, but more or less these are the settings that you would set in your slicer. Layer height affects how many layers your 3D model is sliced in, and affects quality and print speed. Infill decides how solid the part is going to be inside. Whether you want supports in your part to hold up overhangs. Print temperature and speed of printing can be set according to your material and printer. At the end, you'll also get a print preview that shows exactly how the 3D part will be built layer by layer. At the end of slicing, your software will output a file, usually a G-code, which is a file that will tell the printer exactly what to do once you send it to it. Step 4 is printer and material preparation. Now that the digital work is done, it's time to prep your printer. Depending on your setup, this may include loading the right filament or resin, drying the material, especially if it absorbs moisture like nylon or PETG, leveling the bed for FDM or calibrating your build platform for SLA or SLS, setting your print temperature and profiles correctly for the material. Think of this as tuning your instrument before you play. Prep well and print will go a lot more smoother. Step 5 is the actual printing, bringing your model to life. Depending on your printer and the part size, prints can take anywhere from 30 minutes to multiple days. During printing, it's common to also check out the first few layers carefully, because this is where most print failures occur. Check for adhesion. Is the part sticking properly to the bed? Listen for weird sounds, shifts, or pauses. You don't have to babysit the whole print, but knowing what to look for, especially early on, will save you from failed prints. The final step is post-processing or finishing your part. Once your part is done, you're not completely finished yet. Depending on your printing process, post-processing could include removing supports, especially with SLA or FDM, washing and curing resin prints in the case of SLA, sanding, painting, gluing parts together, heat treating or vapor smoothing if you want a next level finish. Now that you have seen the full workflow, you've got the roadmap, which will give you a sound intuition about how to go about working with just about any 3D printer.